Hello YouTube viewers, welcome back to my channel. I'm Sri Tips, and today what I have here is the gold-filled scrap from the wristwatches that I've cleaned up and taken apart. This is all steel. I'm going to throw this away. This is going in the trash. I don't need that. These are the tops and these are the cases, and it's my contention that this material is only gold plated on one side. And so what we're going to do here is we are going to measure this material, see if I can get a weight on it. See if that's showing up right. Yeah. Zero this out. These are the gold filled tops off of the bands. And I'm saying that 1/2 of the material is gold filled, the other half is not, because the gold filled material is only on one side of this. So my contention is that that will cut the yield in half. I've got 44.5 grams of the tops off the bands, and this is the watch casings. That in there now, and we've got 77.8 grams total of gold filled material here that I'll be working with off of gold filled watches. Alright, let's see if we can do some calculations here. We've got 77.8 grams of the gold filled watch cases in here. I'm going to call it 12K, so we multiply this times 12K. Can't do that. 12K is going to be 12 divided by 24, or 0.5. So that's the number we want to use here. Can't multiply it by 12K. We can calculate what 12K is by dividing it by 24. We get 0.5. So 77.8 grams times 0.5 is going to equal 38.9 grams. Okay, this is 1/20th 12K, so we got to multiply this by 1/20th. 1/20th is equivalent to 0.05. So we multiply 38.9 times 0.05, we get 1.945 grams of pure gold from this gold-filled scrap. This gold-filled material is only gold-filled on one side. That only 50% of this is going to be have a gold-filled coating on it. So I must cut this number in half in order to be able to correctly calculate how much gold I can expect to get from this. So we take 1.945 grams from up here times 0.5, we're cutting it in half, and that equals 0.9725 grams of pure gold from this material right here. I'm at my fume hood now. I just wanted to show you this stuff here is highly magnetic. That's okay. We should be able to get this to go into solution with our hot dilute nitric acid. There's probably some iron and some nickel. That's okay. Now what we're going to do is I've got a beaker up here, and I'm going to add some distilled water, about 200 milliliters. Now what we'll do is incinerate this material, get all the combustible stuff burnt off of it. You can tell when it's done when it stops smoking. melting any of it, because then the gold-filled material will tend to alloy. That's something we want to try to avoid here. Just heating it up to redness, burning all the combustible material off of it. Alright, we got that done. Now we're going to take our material and add it to the beaker up here. Alright, I'm going to turn some heat on. It's got 3 settings, low, medium, and high. And I'm going between the medium and the low setting. I'm going to add some concentrated nitric acid now, an equal amount, so that I've got a 50-50 dilute nitric acid solution in here. About 200 milliliters here going in. See, we get an instant reaction. And now, just wait until the base metals and everything gets dissolved off of the pieces of gold-filled scrap from our watches. I think this first edition of nitric is just about over. I'm gonna rinse down the sides of the beaker here. Add a little bit more distilled water and some more concentrated nitric acid. Time right now is 12:20, so this has only been on here for about 10 minutes. There's some more concentrated nitric acid going in here. That's about 100 milliliters. Just let this cook. Turn the heat up a little bit here to just a little bit above medium. That'll cause that solution to boil. The time right now is 1:20 p.m. This has been on boiling now for about an hour, 10 minutes. I'm going to turn the heat off, let it cool down, and we'll get the foils out of that solution. The experiment has been allowed to cool down now. And what I'm going to do is pour it into this filter paper here. Here's a look at our gold foils. Look pretty good. I don't think we need to do any more nitric acid treatments here. I think everything has been dissolved out. It's going to come out. I'm going to run a magnet under here and just see. We got no magnetic material in there now at all. Nothing sticks to the magnet. So I'm going to add this gold-filled foils to the filter now. Gonna get these in the filter. Yeah, those are just foils of what they used to be. Very light. No base metals left in them now. Here's our gold-filled material. It's all just foils of what it used to be. And so what I'm going to do here is rinse this off real good with some distilled water. And then we're going to get this in a melt dish and incinerate it real good. Alright, here we go. We've got everything filtered out now. I'm going to get the foils out of the filter here. That's our foils. I'm going to carefully transfer this into this melt dish. And then I'm going to burn it with a low propane flame here. Just going to heat it to redness now. here's our gold foils, nice and incinerated. They look like gold. What I'm going to do now is transfer these up into the beaker up here. Do this. Put them right up in this same beaker that they came out of. Okay, now we're going to add some hydrochloric acid here to the beaker with the foils in it. I'm going to put in about, I guess enough just to cover the bottom there, maybe 100 milliliters. Okay, here we go. We're going to add some concentrated sulfuric acid here to precipitate out any lead. It's about a half a milliliter. Now I'm going to add some concentrated nitric acid here. I'm going to put about 3 milliliters in here. I'm going to go with 6. Why not? And we're going to turn some heat on and start dissolving this gold. Alright, we're going to pull this down off the heat, let it cool down, and filter it out. Alright, now I'm going to get it filtered out here. It's cooled down a little bit. I don't see any more pieces of gold up in there. Got everything to dissolve. Here's a look at the sediment that's in the bottom of the funnel there. It's all filtered now. We'll take this and transfer it into a beaker, and then we'll add some sodium metabisulfite and precipitate out the pure gold. Alright, let's add some sodium metabisulfite now and precipitate the gold powder. I'm only expecting 1 gram of pure gold from that amount of scrap. So what we're going to do is going to filter it all out of the beaker here in this filter paper now. We get a little bit of the solution on a piece of filter paper here, just to show you that all the gold has been precipitated. Stannous chloride going on the test strip. As you can see, there's absolutely no reaction. And that tells us that all the gold has been precipitated. Okay, here's our pure gold powder. Bottom of this beaker. I'm going to get it down into the filter now. Then we'll get it over on the melt table and melt it up into a little bead or a button here and get a weight on it, get the yield on this gold-filled scrap. Now I'm using concentrated hydrochloric acid to rinse the gold in the filter. Now we're going to rinse it down with a little water here, carefully so we don't poke a hole in the filter. Alright, I've got the gold all rinsed off in the filter here. That's what it looks like down inside. I'm going to take this out now, put it in a melt dish here. We're going to transfer this over to the melt table over here and melt this up into a button so we can get a yield on it. Here's our pure gold bead from the 77.8 grams of gold-filled watches. Let's see what we got for a weight here. .8. I calculated 0.97 or about 1 gram. The actual yield on this is 2.8 grams. So whoever it was that said I shouldn't cut the yield in half because only part of the metal has gold filled on it, kudos to that person. He is right. I stand corrected. Okay, this will conclude the video. Got a 2.8 gram gold bead from those 77.8 grams of gold-filled scrap off of the wristwatches. One of my viewers pointed out that I was incorrect in taking half of the yield away like I did over here. My estimated yield was 0.9725 or less than 1 gram. Before I took half of it away, I was estimating 1.9 grams. And I actually got 2.8 grams. That was my actual yield here. So I stand corrected. That fellow was absolutely right. I should not cut the yield in half to account for the fact that only part of the gold-filled scrap has gold-filled material on it. Looks like the whole thing does. So I stand corrected. That'll conclude the video. Thanks for watching.